Hello viewers, this is Dr. Dheeraj Malhotra. So we have discussed insertion and deletion types in singly linked list up till yet. Hope you have watched all the previous videos uploaded by me. And today we are going to discuss various other operations such as concatenation, reversal and sorting in a singly linked list. So let us start with concatenation of singly linked list. So here we go. I hope it's visible. So concatenation means we are basically joining one linked list after another. So it's a very simple operation. So as you can notice here, with the help of C function, I'm going to explain it. So here we have concatenate function with two arguments, struct node type pointer head 1 and struct node type pointer head 2. Means we have two separate linked lists with head 1 pointer on first linked list and head 2 pointer on the starting node of second linked list. So we are going to concatenate both of these. So how to perform this? We are basically making a temporary pointer PTR as we have seen in our previous algorithms as well. So PTR is initially pointed to head 1, means wherever head 1 is pointing, wherever that particular node is lying from where our list is starting. So PTR will point to the same node and we will move this PTR pointer up till it reaches the last node. And what is the identification of last node? That the address part of the last node always consists of null, and it is the only node where null is stored. So in order to move further, we always use this statement, PTR is equal to PTR next, which means whatever is the address stored in the node where PTR is currently pointing, that address should be stored in PTR, means it's moving to the next node. So as soon as this condition gets false, so we have reached the last node, that means we have reached the last node, and after reaching the last node we will write the null part with the address of the starting node of second list, because we must have moved out of this loop if this condition is false. That means PTR arrow next is equal to null. So we have overwritten this null with the starting address of second list. So this is how we can perform concatenate operation. Now let us see sorting operation. So if you have seen my array videos, so there we have discussed various types of sorting algorithms. So here we will perform selection sort. If you know, selection sort is usually used to find the smallest node in a linked list. So let us see. The sorting function is like we have made two pointers, PTR and temp, and from starting node, see, sometimes we use start pointer as the initial pointer and sometimes we use the convention head. Both are correct. Okay, so PTR is initially pointing to the starting node of the linked list, and then we will move this pointer till PTR reaches last node. So by the help of temp pointer, temp is initially pointed to the next node of PTR. Okay, so if PTR is pointing to the first node, that means temp is pointing to the second node. If PTR is pointing to the second node, then temp is one node forward, means it is on the third node, and so on. So while temp is not equal to null, what we are going to check that whether the node on which PTR is pointing and the information part in that node is greater than temp info, means larger information is stored in the previous node and smaller information is stored in the next node, then we need to swap those information, because we know sorting by default is always in ascending order. So we need to have smaller information on the left node and bigger value of the information on the right node. So like this we are swapping, and then we will move both of them. Then similarly we have reversal operation in a linked list. So in order to perform reversal, again we are using two pointers, PTR and prev. So prev is always on one node behind the PTR. So when PTR is on the starting node, that means prev is at null. So when PTR is on second node, then prev is on first node, and so on. So we will iterate the loop till PTR reaches the last node, and new equals to PTR next. One more pointer we are using with the name new. So new is basically is one node forward to the PTR. So what you can say that if PTR is on second node, then prev is on first node, and but new is on third node. So new is one node forward to the PTR. So new is equal to PTR arrow next, means next node to the PTR. And then what we are going to do, because we know prev is on the previous node, so we have stored prev address in PTR next, means wherever PTR is currently pointing, its address part should be overwritten by whatever stored in prev, means the pointer will start pointing in the reverse direction, and then again we move prev and PTR. So my suggestion to you is that you can dry run these programs and see my next video where we will discuss the overall implementation. Thanks for watching.